All right, so we got problem 9.34. This problem is mainly to show how to solve for uh, whatever value they're giving us using maxima. Um, so yeah, I'm gonna go ahead and label the circuit. So I'm gonna call this bottom portion, the drill, label the ground first. So this would be VG. I'd call this V1. Um, I can call this little portion there V2. I can call this V3. So then we can label our currents. So I'm going to go ahead and call this current I1, current going across here, I2, I3, current here, I4, I'll call this I5, and then I can call this I6. Okay, so we can go ahead and write our KCL, right? So IG is equal to I1 plus I5 plus I2. Then we know that I2 equals I3 plus I4. And we know that I6 is equal to I4 plus I5. So our equation for components, we know that I1 is equal to V1 over negative 10J. I2 is equal to V1 minus V2 over 16J. Say I4 is equal to V3 minus VG over 20. Say I2 again is, I skip that, V2 minus V3 over 12. And I3 is V3 over 5J. So we got, VG, IG, V1. So V2, V3, I1, I2, I3, 4, I5, I6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I'm gonna go ahead and open Maxima. Show you guys how to do this. You got 8. All right, so IG. Well, we know these values, so essentially we have 11 equations. I'm just gonna add it as I go. 5 plus L2, 2 equals L3 plus 4, 6 equals 4 plus I5, A1 equals V1 over negative 10 times percentage I. 2 equals to V1 minus V2 over 16 times percentage I. I4 equals to V3 minus VG over 20. 2 equals to V2 minus V3 over 12. V3 equals to V3 over 5 times percentage I. We got 1, 2, 3, 4, 5, 6, 2, V3. Okay. So we're missing these. VG equals to 100 minus 50 times percentage I. G equals to 30 plus V1 equals yeah, VG, IG, and V1. So there we go. Essentially, our J, we replace it for percentage I, and we would get that value. So I5 is, so we want to look at the value of I5. So where is I5? I5 is here. So because we want to look at the current going across whatever impedance, whatever this Z value is, right? So I'm actually gonna copy this and paste it on this OneNote. Okay. I don't think they'll fit. Whatever. Yeah. So going back to the problem, so we want to look at I5 because I5 is basically our IZ, or the current going across the Z component. So since I5 is 30 plus 10J, and we know that we know that V equals I times Z, right? And we want to find Z, so V equal to Z is equal to V over I. And since we look at the direction of our current, so it's going to be V1 minus VG over I, or I5, right? So then with the values that we get from maxima, so we know that VG 100 minus 50J, and V1 is 30 or 140 plus 30J. So let's go ahead and do the math there. 140 plus 30J, right, minus 100 minus 50J. And I5 is 30 plus 10J, right? So you can go ahead and do that. So we get 40 yeah. Yeah, V1, yeah. 100. I'm looking at this right. Okay. 40 plus 80 J or 30 plus 10 J, right? And so then we could plug this in. So again, say we have T equals 2. We can do this again in maxima. That's loud. Do that there. Plug that in. Let's see. I don't really want to do the math, so I'm just going to have the computer do it. Over 30 plus 10 times I. See. So that would be our result. G would be 2J plus 2 or 2 plus 2J. Doesn't matter. So this would be our equivalent for Z. And yeah, so the main outcome out of this is for maxima, J would be a function, would be percentage I. And just to make sure, multiply whatever constant you have with that, just to make sure your equations aren't wrong or there's an error that shows up or whatever. But yeah, thank you so much.